most powerful tools we have in our endodontic arsenal is the electronic apex locator. Now, most of you will become proficient in using the device. However, it sometimes is challenging to describe the fundamental principles that are involved with its function. Much of what I'm going to discuss comes from this paper by Nukufar, and although he uses this paper to discuss all the different types of electronic apex locators, I'm going to focus in on the Root ZX2, which is the one we primarily use in our dental clinic. In order to understand the concepts in this article regarding impedance ratio apex locators, you must first understand what a capacitor is. In this picture, this is a very simplistic capacitor, but these are two metal plates with air in between the two. The air is a non-conductive medium, and of course the plates are conductive. So in this example, the air is considered a dielectric, the non-conducting space in between two capacitor plates. If you're like me, you are probably overwhelmed with all the different equations found in this article. It's not important that you remember all of the particular equations, but there are some important relationships to be aware of. Most important is going to be the distance between capacitor plates. Now you'll see in the next slide what I mean by a capacitor plate in our endodontic experience, but just know that as the distance between capacitor plates decreases, the capacitance actually increases, the impedance decreases, and perhaps most importantly, the impact of frequency on impedance increases. So the opposite, of course, is true, and so as you have greater distance between capacitor plates, your capacitance decreases, impedance increases, and there's little impact at all of frequency on impedance. So in other words, if you have unlimited distance between capacitor plates, as you have before you enter the file into the canal, then changing your frequency of your apex locator should have no effect at all on the impedance, and therefore create a ratio, an impedance ratio, of as close to 1 as possible. Also important to note is the larger or the higher frequencies result in lower impedance. So typically the impedance ratio is going to be 1 or below. So when we're talking about capacitor plates in endodontics, and specifically with electronic apex locators, our plates are actually the file itself, then the periodontal ligament and supporting structures. So if you can, in your head, imagine that these two, instead of a file and periodontal ligament and bone, are rather two capacitor plates, then the concepts will become a little bit more easy to understand. Returning to one of the equations listed in the article, X subscript C, which is capacitive reactance, equals 1 over 2 pi times the frequency times capacitance. Important to all of the understanding that we're going to go through for the rest of this video is that both frequency and capacitance are both found in the denominator. The impact of this is that if you have a very low capacitance, the frequency will have very little impact on the overall capacitive reactance. But as your capacitance increases, changes in frequency will become more important. So for example, if you have a capacitance close to 0, 0.001 or whatnot, then your frequency can be high or low, but at the end of the day, because it's found in the denominator with capacitance, it will have very little impact on capacitive reactance. Now for simplicity's sake, we will refer to X subscript C, or capacitive reactance, as the impedance, represented by Z. Remember again that capacitance equals dielectric constant, which is a constant value for whatever is within the space between the capacitor plates. So in this case, that would include dentin, pulpal tissue, fluid within the canal. times A, which represents the cross-sectional area, over D, which is the distance between capacitor plates. And once again, the capacitor plates in our example here are represented by the file and the supporting tissues. The important part of the electronic apex locator algorithm is the impedance ratio. So once again, that's the high frequency impedance over the low frequency impedance. So before we enter the file into the canal, obviously the distance between our two respective plates is quite large, which means our capacitance is low, and therefore the frequency of the electronic apex locator has virtually no impact on impedance. And therefore, our ratio of impedance is fairly close to 1. As our file enters the canal, the distance between capacitor plates decreases, which increases capacitance and slightly increases the impact of frequency on impedance. However, the effect is minimal and the ratio is still close to 1. While traveling further down the canal decreases that distance further, increasing capacitance and increasing the frequency impact on impedance, it still doesn't begin to make a difference, practically speaking, until the file has come very close to the apex, ideally in the apical constriction. At that point, with the reduced distance, the increased capacitance, and therefore the increased impact of frequency on impedance, we start to notice that the impedance ratio decreases significantly. Were we to take the file even further into the tissues, there would be no capacitor, and instead we would be looking at a simple function of electrical resistance. To briefly summarize, when we consider the file and the supporting tissues of the periodontium as capacitor plates, the decreasing distance between the file and the tissues results in an increased impact of frequency on the impedance. Therefore, two separate frequencies, high and low, will create a ratio much less than 1. However, if the distance between the two plates, or the file and the tissues, is great, then there is little impact of frequency on impedance, and therefore a ratio of a high frequency over a low frequency is close to 1. Hopefully this helped you understand a little bit with the impedance ratio apex locator. If not, feel free to ask me questions and let me know where I can improve the video for future.